So we'll give 8 more minutes for everyone to join, and then we'll start. Megha, do you have like a window on your screen that says please note or something, and then the last words is application somewhere on your screen?
No, it's not coming.
So I see this orange box pop up.
Yeah, it's there. It's there.
Please move this window away from chairs. And I don't know.
Yes, it's there.
I don't know what window that is, Megha.
I don't know, it suddenly appeared. No, now it is gone. Yeah, no, save.
Can you like close all the windows, maybe?
It's only Kahoot I have opened.
From the shared application.
It's only Kahoot and Zoom on my screen.
Yeah. Is it possible to right click and delete that window?
Shall I reshare my screen?
Sure, let's try that.
Is it there now?
No, it's not there.
No, it's gone now. All right, let's get started. Hey, good morning, everyone. I'm so happy to see you all again in our second D2S session. The session will be on chemistry and with the topic metallurgical magic. Next slide, Megha. So before we get into the session details, let me introduce Adhyaapan to you guys. So Adhyaapan is an inclusive ecosystem where in-house educators, industry experts, and entrepreneurs have a unified vision to kindle curiosity of students between grade 8 to grade 12 and then transform the way they learn. And how we do this is our content will tell the students why they learn what they learn at school. It will show them the real life applications of what they learn. And through those real life applications, we show them the career opportunities and employable skills to develop so that they have a good career awareness through the like early on in their lives, basically. So this way, our intent is to make sure that the students understand or fully understand the concepts. And we believe that only when a student understands the concept fully, can they be innovative. And through our real life applications and our industry awareness, we hope to make sure, or we hope that the student finds their passion through all of these career applications that we show in order to make sure that they make a good career progression with making informed choices. Next slide, Megha. So today we have with us Megha Gupta, our academic expert, our science educator and content developer. Megha, welcome today and thank you for doing this for Adhyaapan today. Mega has two bachelor's degrees, one in science chemistry, and then the other one in education from University of Himachal Pradesh. From there, she went on to do her master's of science in chemistry as well from Madurai Kamaraj University. She does content development. She not only does content development but also designs curriculum and teaches, and she has a teaching experience of over 10 years in schools in Mumbai. Our industry expert today is Mr. Sabir Chowdhury. Sabir is a geologist. He has a undergraduate degree in geology and a master's of science degree with first class, both from University of Calcutta. Mr. Sabir has been closely associated with the government of Jharkhand through their working in their Department of Mines and Geology. He has done several projects for the government, and is an expert in iron ore and in iron ore studies, manganese ore studies, limestone ore studies, and currently he is working on graphite mineralization at Tanzania, East Africa. So we have two speakers, and how our sessions are going to be structured is we will have the content, the science content that Megha will explain, and then anywhere we will have panel discussions and questions about careers and real life applications, which is where Mr. Sabir Chowdhury will come in. So the session would be structured in a way that both the speakers will be talking at various parts of this session, so that you guys can understand the content really well from an academic expert and an industry expert as well. So over to you guys, and hope you guys enjoy the session. Over to you, Megha.
Thank you, Arjun. A very good morning to everyone. I welcome you all here. Let's see our learning objectives for the day. In our today's session, we will be discussing about metal age evolution, comparative study of properties of metals and non-metals, metals and metallurgy, uses of metals in next-gen technologies, metals in space, application of rare earth metals, metals as biomaterials in body, unique applications of chemistry, career aspects, and career pathways. So stay tuned till the end of the session. Let's get ready for our session with this Kahoot. By the time other participants are joining, I suggest you all to play this Kahoot to do a quick self-reflection on metals and non-metals. I request Arjun to give the Kahoot link in the chat box. You can go to kahoot.com and you can also type the game pin given here on the slide. It's 1917480. I repeat the game pin 1917480. I can see Naina Unnati on my screen. Thank you for joining the Kahoot, guys. Anyone still trying to join the Kahoot?
Ma'am, it's not opening.
It will start when I will start it. So I'm waiting for more participants to join in. I'll wait for 30 more seconds and then I'll start the Kahoot. Okay, we have 4 participants. I'm expecting more. Quickly join. Okay, let's start the Kahoot.
अरे आई ना
Okay, where can we find metals on the periodic table? On our left hand side. Okay, Unnati is leading. Next question. Is calcium a metal or a non-metal? Yes, calcium is a metal. Which of these is a non-metal? Read the options given on the slide. Which of these is a non-metal? Okay, so the correct option is krypton. Oh, SP is leading. Next question. Which of these is a metal? Again, read the options given carefully and then choose the correct color. Which of these is a metal? Sodium. Yes, sodium is the correct answer. Which of these are good conductors of electricity, metals or non-metals? We have 2 more questions. Let's see how many of you will give correct answer for this question. Wow, wonderful. All are correct. Metals are good conductors of heat and electricity. Okay, SP is still leading. What type of substance is found on the right-hand side of the periodic table? Non-metals, yeah, correct. Last question. Which of these is a property of metal? Malleable or brittle? Yes, malleable is the correct answer. Let's see the leaderboard. So we have AD on third position, Unnati on second, and SB on first position. Okay, congratulations everyone. We have runner-ups, Naina and Advait. I'm glad to have wonderful participants like you. Okay. I'll just go back to my presentation. Am I presenting my screen?
Yes, Megha, you need to have slideshow again. You exit out
Yeah.
of it when you went into Kahoot.
Okay. Okay. So a picture says 1,000 words. What does this image tells you about the evolution of men? Take 10 seconds time to think and then type your answers on the chat box. Yes, it tells us how humans have evolved with time. Absolutely correct, Mahima, Unnati, absolutely correct. So do you think the same has happened with the uses of metals as well? Yes. Since the beginning of civilization, people have used stones, ceramics, and later metals found close to the Earth's surface. They were used to make early tools and weapons. Can you think of the first metal that man discovered in 9000 BCE? You can type your answers on the chat box. First metal discovered by humans. Okay, Mahima says it's arsenic. Okay, Diva says copper. Hema Balaji says bronze. Unnati says copper. Okay, so the correct answer is copper. It was copper. You know, during the 20th century, the variety of metals used in society grew rapidly. And in the modern era, we harness plethora of metals from lithium to uranium, calcium to platinum. If we want to classify our current age by the metals, it would probably be the titanium age. Any guesses why it would be titanium age? Yes, because of the unique properties of titanium and its alloys, they are used in the airplanes, missiles, and rockets. Let's move forward and discuss the properties of metals and non-metals. You must have observed people wearing jewelry made up of gold, platinum, silver. Have you ever thought which property of metals make it possible? Can we use non-metals like sulfur for the same purpose? Why or why not? Think. Unnati says no. Okay. Yes, Mahima, absolutely correct. Ductility. Yes, they have luster. Absolutely correct. Diva, Arun, luster. Yes. Yes, metals are malleable and ductile. They can be hammered, shaped, and rolled into very thin sheets without rupturing, whereas non-metals are non-malleable and non-ductile. Guess, how much gold do we need to make 2 kilometer long wire? Yes, Anshu, luster, ductility, malleable is the correct answer. Now think, how much gold do we need to draw 2 kilometer long wire? 1 gram gold. Absolutely correct. Yes. 2 kilometer length can be drawn from 1 gold of wire. Absolutely correct. Now think about the bells. They are made up of metals. Imagine a bell is made up of non-metal. What will happen? Why bells are made up of metals only? No sound or less sound. Absolutely correct. Yes. Sound will not come. Yes, Arun. Yes. So bells are made up of metals because metals are sonorous. When hit with a hard surface, they produce a prominent and a peculiar sound, whereas non-metals are non-sonorous. We know that metals are good conductor of heat and electricity. Even though the silver is the best conductor of electricity, still it is not used for electrical wiring in the houses. Why? We use copper for the same purpose. Why don't we use silver? Absolutely correct, Suman. It's costly. Yes, because it's very expensive. Although silver is a noble element and it is used for making jewelry, we don't use it for electricity purpose because of economic value. I'm liking the way you all are giving answers in the chat box. Yes, Mohammed, copper is cheap. Absolutely correct. Now let me ask you more questions on this. So based on physical properties, we can differentiate metals and non-metals, but there are some exceptions. Can you tell me a non-metal that is lustrous? We know metals have lusters, non-metals are non-lustrous. Absolutely correct, iodine. Iodine and graphite are the exceptions in absolutely correct. Yes, graphite. So iodine and graphite both are exceptions in non-metals because they have luster. Metals are hard. Can you give me the names of few metals which are so soft that they can be cut with the help of knife? Sodium, absolutely correct. Okay, Na, sodium, yes. Yes, Suman, Mahima, sodium and phosphorus. Okay, phosphorus. Think, Mahima, phosphorus is a metal. Potassium, yes. So sodium and potassium, they are weak metals and they are so soft in their texture that they can be cut with the help of a knife. Now think about non-metals. They are generally soft. So can you think of a non-metal that is hard? Diamond, absolutely correct. Diamond is hard. So again, it's an exception in non-metals. Okay, one more question for you all. We say metals are malleable and non-metals are non-malleable. Can you think of a metal that is not malleable? That is brittle? Zinc, absolutely correct. Zinc is the correct answer. It's so interesting to observe chemistry in our everyday life, isn't it? Let's take more examples to understand it better. When we cut an apple and keep it in open for some time, it turns brown. Yes or no? Okay, Suman is super fast. She is giving me the answers in advance. Okay, great, Suman. Great job. Okay, also, iron things get rusted. Why? They undergo some chemical reactions. What are these chemical reactions? Think. Okay, so as Suman has already given me the answer, yes, Mohammed, absolutely correct. It gets react with moist air, rusting, corrosion. Absolutely correct, guys. So the reactions they undergo are the oxidation reactions. So now can you think of some applications of oxidation reactions in our everyday life? Think of some applications. Where do we use oxidation reactions in our day-to-day life? Combustion, absolutely correct, Suman. Respiration. You mean to say respiration, I guess. Yes, respiration, correct. Also, food turns rancid when the fats and oil within them get oxidized and the taste and color of the food changes. This is called rancidity. Yes, Mahima, cycle chains get rusted. Absolutely correct. So this happened because of these oxidation reactions. Metals react with the oxygen present in the air and turns into metal oxide. Absolutely correct. Let's take some more examples. Let's look at the images on my slide. You must have observed a pungent smell during roasting onions, a stinking smell of stagnant water in grains, or the burning of rubber. Can you all think of a non-metal that is common in all the activities that is responsible for all this thing? Which non-metal is responsible for this? Okay, I'm getting few answers in the chat box. Oxygen, hydrogen. Think. It's sulfur. Okay, now two more questions for you all. Think quickly and tell me any metal, any non-metal which is used as a bleaching agent. Good try, Namrata. Arun, Suman, yes. Chlorine, yes, Anshu, chlorine is the correct answer. A non-metal that is used in matchstick. Sulfur, is it sulfur? Phosphorus, yes, Diva, Mahima, absolutely correct. It's phosphorus. We use phosphorus in matchstick. Now, some interesting facts to share. Do you know we use liquid hydrogen as rocket fuel because it is light and extremely powerful rocket propellant. It burns with extreme intensity. We all enjoy sparklers during celebrations, yes. But have you ever thought of the different color flames? It is because of different metal salts present in them. So calcium salts give you orange, copper salts give you blue color, barium salts give you green color flames. Okay, one more interesting fact for you all. You all must have seen the silver or the aluminum foils in the sweets. Yes or no? How many of you like to eat laddus or silver katli or kaju katli wrapped in these foils? What are these? The silver color or the golden foils on the food. What are these? Yes, absolutely correct, Arun. These are metals. These are pure forms of metals and are safe to eat as they are non-ionic forms that won't be absorbed by the body. So isn't it all interesting facts? Now, let's quickly revise the keywords we have learned so far. We have talked about malleability, ductility, sonorous, conductivity, oxidation, combustion, and rancidity. Now again think, why do we use stainless steel utensils in our kitchens? Is there something specific about them? Any specific reason for using stainless steel utensils at home? Do not rust. Okay, yes. Alloys, absolutely correct. What are these substances called? These are alloys. Okay, can you give me the composition of stainless steel? Is made up of what? Yeah, it is an alloy. It is made. Okay.
Long.
Okay, so it has 70% of iron, chromium, and nickel. It's an alloy which makes it lustrous, hard, and resistant to acid and base. And as you mentioned, it do not get rusted as well. Think of the duralumin. It is again an alloy which is made up of aluminium, 95%, magnesium, and manganese. And because of its unique properties, it is light yet strong and used to make the bodies of airplanes. So these substances are alloys. Can you quickly think of the reason for alloying? Yes, absolutely correct, Sumin. Aluminium, copper, magnesium, these all are used in aircrafts. Absolutely correct. So yes, so what are alloys? So as I said, these are the homogeneous mixture of two or more elements. And we use alloys, we make alloys because they modify appearance and color, they increase the tensile strength, and they also increase the resistance to corrosion. Now you must be wondering, why do we need to study about alloys? So here is the reason. There are some possible careers. You can be a material scientist, manufacturing engineer, aircraft structural analysis engineer if you will study in details about alloys. Isn't it interesting? So now we have discussed so many practical applications of metals and non-metals in our day-to-day life. Now the question arises, from where do we get these materials? Think. Okay, yes. Yes, Arun, Mohammed, Suman. Okay, Suman, I asked, from where do we get these minerals? From ground crust of the earth. Very good, Mahima. Yes. So we know that the earth's crust is the major source of metals. Metals are found in combined state. They are mixed with other substances. So they have some impurities in them like silica, soil, sand. These rocky impurities, yeah, before I am saying, I am very impressed. Suman is giving me all the answers. Very good, Suman. So these rocky impurities associated with ores are called matrix or gangue. Okay, what is mineral? So the minerals from which metals can be profitably extracted are called minerals, are called ores. Minerals are typically solid inorganic crystals, you can see on my slide here, and they are formed by geological processes. The flux combined with the impurities present in the form ore to form what? Quickly type your answer in the chat box. The flux combines with the impurities present in the form to form an easily fusible material called, absolutely correct, slag. Now, can you tell the name of the process of extracting metals economically from their ores? What do we call that process? Here we go. Yes, metallurgy. It's metallurgy. So when we are talking about metallurgy, mining is one way to extract the minerals. Some examples of substances that are mined can be seen on the slide as coal mining or the gold mining. Now, again, you must be wondering why we should study about all these minerals, ores, flux, slag. So again, we have possible careers here. You can be a mining engineer, geologist, metallurgical engineer. So to learn more about metallurgy, we have our expert here today. Let's call our expert, Mr. Sabir Chaudhary, who is working as a geologist.
Good morning.
Very good morning, sir.
Good morning, ma'am.
As we were discussing metallurgy, I thought you would be the better person to give us insight about the process. So children, stay tuned and listen carefully what our expert is sharing with us. My first question is, what is geology?
Well, thank you, ma'am. Geology is the scientific study of the earth. Okay. It also tells us about the formation of the earth, its distribution, and the distribution of the planets, how the earth forms, its history, processes of history. As you can see in the images, like the upper part of the earth is called crust, Then comes the mantle. It is divided into two parts like upper mantle and lower mantle, and then the outer core and inner core. Okay, all the studies, all the scientific studies, the beneath the earth surface, that actually deals with our geology. Like you can see
It's
the yes, ma'am.
so it's so interesting to know more in details. Now I'm more curious to know what geologists do and what is the importance of geology.
Yes, well, for a geologist, that actually geologists do to understand the history of the planet, history of the earth, how it was actually, and the events and the processes that occurs in the past. Okay, like how it was earlier, like all the plates are in a same way, and how the movements of the plates done. Okay, so geologists actually engaged in different processes landslides, earthquakes, floods, volcanic eruptions, whether it is active or dormant. There are natural hazards, there are several natural hazards, so geologists have to look after all those, and to control the natural hazards, how to overcome, how to reduce the hazards, how to reduce the impact of the hazards, and what are the possible areas where the hazards can happen, how to reduce. Okay, so there is in a brief, we can prepare a map of a floods. Generally there is a map we prepared since last few years. There may be possibilities of floods, so how it actually occurs, what's the reason behind it, and how to overcome that. Okay, uh, again other part is to locate the natural resources, like how we prove a new area, new potential areas. Okay, to where there is a possibilities of economically viable minerals or ores, whatever. Okay, that actually in a brief is geology, importance of geology, and in a daily life what geologists actually do.
So can you throw some light on what are minerals?
Well, minerals is a naturally occurring inorganic substances which have its definite crystal structure and with a proper chemical composition. Okay.
How minerals are formed?
Minerals are actually formed from the molten magma or the lava, and after that when it comes to the earth's surface, and after the chilling, after the cooling process, it takes several times, lots of years, like in geological time scale, we must say in billions of years, and then it's after solidifies with and after with chemical reactions with seawater or whatever, with sometimes with the airs also. So how actually minerals are formed from the main source is from the molten lava.
I'm very sure our students are enjoying all these informations. So can you please tell us more about the minerals, different types of minerals?
Is the in the nature there are lots of types of images, in the images you can see few of the examples, a very common example is quartz, ferromanganese, like amethyst is like we use in our ring, we used to wear in our fingers. Also for galena is also gemstone. Common ore of iron, it is a hematite and calcite. There's lots of examples you can found in our nature.
So can you tell us more about the rocks? What are rocks and how are they formed?
Yes, rocks is also a naturally occurring processes, it's composed from the solid crystals of different minerals. Okay, that the rocks is basically nothing but the aggregate of minerals. Okay, and there are different types of rocks, igneous rocks, sedimentary rocks, metamorphic rocks. These are common types of rocks.
So we generally discuss that all ores are minerals, but all minerals are not ores. Can you please help us
Yes.
understand how minerals are different from ores?
Yes, like as you said, all the ores are minerals, but all the minerals are not ore. For that, I have example over here. Like ores is what ores is like, from where we can found mineral, we can found any element or anything that is economically profitable, economically viable. But for minerals, minerals may not be economically viable. Okay, so all ores are mandatorily economically well. Then only we can consider this can be a ore. Like here, I have two example. Like one is laterite, another one is bauxite. Okay, for laterite, it contains alumina. It contains alumina, but we can't extract aluminum from laterite. Okay, but for bauxite, bauxite is actually treated, actually considered a ore for aluminum. Okay, because for profitably we can extract aluminum from bauxite, but not from laterite. Still, it contains aluminum.
So
Hope
we
you
got an
understand something. Do you have any questions, students? You can write it in your chat box, please.
So now we
Okay.
got that opportunity to know more details about from you. So I'm more curious to know, can you how do you identify the suitable sites for extraction?
Yes, being a geologist like me, like uh, we have to first, move into the field, and we have to map our study area. That's the first thing we have to do. Like, what are the exposures we have? We have to make the samples. We have to take the samples from the surface, from the study area, to study the initial part. Okay, and after the mapping, we may take the remote sensing study that actually happens through the satellites. From there we can see, any difference from the any differentiation is present or not. Okay, after to increase the confidence level, like we have to put boreholes from the study area to the study area, and we have to go through the geophysical methods. There are several methods, and ultimately we have to take the samples, and we have to make sure that presence of particular elements are there, whether it is economically viable. For that, we have to make the XRD XRF. That is a high study for level to increase the level of confidence. For it should be the petrographic study should also be there. Okay, that actually confirms you that yes, we can, there's possible, that can be a possible mining site. Like you can see, this is a diamond mining site. Okay, yes, actually diamond can be found in very depth up surface. Okay, so you can see that there is a huge depth, like around 100 meters. Okay, so to maintain the pressure and temperature to form diamond, that actually we have to mine out, we have to go through the several depths, like for diamond mine. But for iron ore mine, it is not take that much of depth, because generally iron ore occurs near the earth surface only. So it we can follow the open cast mines. In case of diamond mine, we can still follow open cast method also for underground mining. Yes, this is a satellite image where we can, understand something more about the details. That is a famous mines of Noamundi area that is situated at Jharkhand. That is a very old mines. You can see the several benches, like whenever you are extracting minerals from the earth surface, and after a certain depth, you have to reach there. To maintain that, one have to maintain the benches, like to move the vehicles, to move the depth, more depth. Okay, and there are some tailing plants like stagnant water you can see from the images. Yes, that is a tailing pond for beneficiation, for any kind of beneficiation. And overall you can see the how actually mines looks like from the satellite image.
So this all made me more curious to know more about the extraction of metals. So can you give a specific example to help us understand the extraction of metal in the Earth's crust?
Yes, sure. Like for that we have to put boreholes, like as I said earlier. From that we have to put boreholes up to hundreds of meters. Like you can see the in the top part there's some clay. Also the dark brown color, that actually existence of iron. And what we do as a geologist, we have to take the samples from here and we have to make sure that whether the presence of iron that is economically viable or not after commissioning of a mine. Okay, that we have to confirm, that we have to put the reports to our team, that yes, we can do mining over here. We can profit, we can make sure that we can make profit from that area, and we can extract iron from that area. I'm talking about iron ore only. But there is several color variation are there. So we have to we have to detail the study for the variations of the colors, what are the mineralogy present over there. Yes, that's it. Like, and after that we have to make sure after the chemical analysis report.
Okay, sir, I also want to know how the role of a geologist differ from a mining engineer.
Yes, yes. Actually, as I said, like a geologist, for to open a mine, that roles for a geologist that plays first. Okay. After the exploration, after the several studies like remote sensing studies and boreholes like mapping, a geologist have to prove that yes, that particular area is mineralogically profitable. We can start mining over there. Okay. And after that the role of a mining engineer actually comes, that how the planning of a mine can be made. Like he is actually responsible for designing of the mines, the safety aspect of the mine, and production planning. Okay, for the running mines, a geologist is responsible for the quality control to achieve the grade. And for exploration part, like the whether the ore continues more depth, or how can we to instruct mining engineer how we plan a mines, like in this way mineral actually occurred. So and with the help of softwares also, geologists actually suggest mining engineer to like plan this that way, to proceed further to winning of new mineral bearing zone in a mine. Okay, for this actually I'm putting example, one of the famous geologists, Mr. P.N. Bose, Pramodnath Bose. He was a famous geologist of early 19th century. Most of you may be heard about the mining company like Tata Steel. Actually, he suggested and he discovered the new iron bearing areas in Jharkhand and Odisha, and he suggested that time Mr. Jamshedji Tata to to start operation of a mines, and actually that is the output we are getting for today. There's a big steel plant, and serving the nations. Like the today's output is what he actually discovers in that particular time. Okay.
Thank you so much for giving us wonderful information, sir. Dear students, if you have any question for our expert, you can type that in the chat box. Keeping time constraint in mind, let's move ahead and summarize the keywords that we have learned so far. We have talked about alloys, mineral, ore, metallurgy, extraction, slag, GAN. Now think, do metals exist in space? Yes, we have metals in space too. Are asteroids? Minerals that can be found in asteroids are iron, nickel, platinum, osmium, etc. So our asteroids are rich in minerals. You know, osmium is used to produce very hard alloys for fountain pens, pen tips, needles, and electrical contacts. It is also used in chemical industry as a catalyst. Now you must be thinking why we are talking about asteroids here. So we have a possible career choice here as in asteroid mining. Now let's talk about the elements for future technologies. You must have heard about electric revolution. So lithium is a crucial ingredient of lithium ion batteries. They are used in everything from smartphone to electric vehicles. It is the battery of choice for most car makers, for example, Tesla, BMW, Ford, Nissan, because it's a type of rechargeable battery that is used in the electric vehicles. And once the electric vehicle battery loses its capacity to power a vehicle, it can be used to power a home or building by contributing to a battery storage system. Now watch this video to know how free electricity can be produced from salt water.
Mika, can you please pause the video and share the video again with sound? Like when you share screen.
Are you able to hear now? Was it audible now?
No, Mega. So when you share your screen on Zoom, please check that box as share sound. Like on the share screen, maybe. You can stop sharing, Mega.
Now?
Yes.
Now is it audible?
Yes.
I'll play it from the beginning. I just want to confirm whether my screen is visible.
Yes, Mega, go ahead.
This is Waterlight, developed by the Colombian renewable energy startup EDINA. It's a revolutionary lantern that generates light and power by using one of the most precious natural resources on Earth, sea. Using just 2 cups of salt water, this beautiful lantern can create clean and renewable energy for up to 45 days. Waterlight is life-changing for communities who live in remote, off-grid areas without access to reliable electricity. Additionally, Waterlight is eco-friendly, being 100% recyclable and waterproof, so it's durable and sustainable regardless of where it ends up. The Waterlight also has sacred ancestral ties. Design is inspired by the Colombian Wayu community and their ancestral connection with the sea. This indigenous community lives on the remote La Guaira Peninsula that spans the border of Colombia and Venezuela. This access to electricity fosters economic growth and improves their quality of life. Before, the fishermen were unable to fish at night. Children had to do their homework by candlelight, which was hazardous. Artisans were unable to fill their orders, and cell phones couldn't be charged. Now all of that has changed. So how does salt water generate electricity? This incredible lantern utilizes the ionization of an electrolyte composed of salt water, which converts the magnesium inside of the lantern. More specifically, it has a specifically designed electronic circuit that manages to extend the transfer of these ions from a saline medium to convert them into convenient and instantaneous energy. The electrodes of the salt bridge enable the bringing of energy from the salt water, an already established process, but with the electronic circuit. This small yet mighty circuit makes it possible to extract around 500 watts for each liter of water. Waterlight's possibilities are endless. It can benefit off-grid communities in need of an electrical source to supply light, charge a mobile phone, or listen to a radio. It can also serve the recreation industry for outdoorsmen or women who are camping in remote locations, and education for turning on a computer or a television. Isn't salt water simply amazing? That's all for today. If you enjoyed this video,
So isn't it amazing, a step towards the green revolution? Okay, let's discuss the application of nuclear energy. As you know, nuclear power comes from nuclear fission. Nuclear energy is created when uranium atoms are split in a process called fission, in which a tremendous amount of energy is released. This energy can be used for generating electric energy in medicines, for scientific research, in food and agriculture, and for space exploration. Did you know 1 gram of uranium-235 can produce electrical power that can be produced by using 3,000 to 4,500 tons of high-grade coal or 2,000 tons of oil? Now let's talk about the rare earth metals. What are rare earth metals? You can quickly type your answers in the chat box. What are rare earth metals? These are a set of 17 metallic elements. These include 15 lanthanides on the, yes, absolutely correct, Anshu, lanthanides on the periodic table, plus scandium and yttrium. These are rare earth metals because they're always found in combination with lanthanide and are never found in the nature as free elements. Now, how are these useful to us? So if you see, rare earth elements are necessary components of more than 2,000 products across a wide range of applications, especially high-tech consumer products such as cellular, telephones, computer hard devices, electric and hybrid vehicles, flat screen monitors, and televisions. The main other uses of rare earth elements are in permanent magnets, phosphorus in color television tubes, X-ray tubes, fluorescent lamps, electronic and computer devices, and lighter flames. So you can see how, these metals are magical in itself. Now let's discuss the importance of elements in our body. Do we also have elements in our body? Let's explore. So if we talk about the hemoglobin in red blood cells, it contains iron elements, and the deficiency of iron leads to anemia. We all know that. Can you think of more such elements that are present in our body, and what may happen if there is deficiency of them? Take 20 seconds time to think and then type your answers on the chat box. Elements present in our body and what may happen if there is deficiency of them. Calcium, absolutely correct, Arun. Anshu, potassium, very good. And deficiency of these minerals leads to what? Sodium, yes, absolutely correct. We have phosphorus that is used for DNA synthesis. Yes, absolutely correct, Arun. Loss of bond strength. Okay, tell me which element is responsible for goiter. Deficiency of which element causes goiter? Yes, Mahima, Anshu, absolutely correct. It's iodine. One more element of One more example of such an important element is zinc, which became more popular during this pandemic. So can anyone tell me why? Why zinc is so important for human body? How does it helps us? Immunity, absolutely correct. Hema Balaji. Yes, zinc-rich food plays an important role in boosting immunity and preventing infections. Zinc is an essential micronutrient that regulates cell health and survival. Now let's discuss metals as biomaterials in our body. Absolutely correct, Mahima. It controls metabolism. Absolutely correct. You must have heard about a person who went through heart surgery or a dental implant or a fracture. Which metal is used for such cases? Calcium. Calcium, okay. For the dental plant or the pacemaker you see here with the heart or these pins, what are these made up of? These are made up of titanium. So as we discussed in the beginning also, titanium and its alloys are widely used for medical and dental implant devices because they show excellent corrosion resistance and good heart tissue compatibility. Now you must be wondering why we should study metals as biomaterials. So again, we have some possible career choices here. If you will study metals as biomaterials in details, you can be orthopedic surgeon, transplant surgeon, or dental surgeon. Last but not the least, some eureka moments of chemistry. Observe the firefly. Its glow is a chemical reaction triggered by oxygen in the firefly's light organ. Can you name this phenomenon? Yes, it's bioluminescence. Let's take some more examples. Have you ever thought why it is advised to brush your teeth daily? Am I audible?
Yes, Megha, you are.
Okay. Because the chat option I can't see now, I guess. Yes, so brushing teeth with toothpaste, which is basic in nature, neutralizes the acid that is produced in mouth and prevents tooth decay. Okay, how does antacids help in case of acidity? Acidity can be neutralized by taking a mild base such as milk of magnesia that helps to relieve acidity. Why does an ant bite irritates? Again, when an ant bites, it injects formic acid into our body that causes irritation and pain. And if that area is rubbed with a basic substance such as baking soda, it neutralizes the acid and helps to relieve the pain. Again, can you think why do we cry when we cut on onions? Again, the sulfur compound present in onions get mixed in air and irritates our eyes. Now let's invite our expert again to have more clarity on career aspects. So I welcome you again, sir.
Thank you, ma'am. Yes, to choose geology as your career path, you have to choose science stream in your 11th and 12th. Okay, then you have to complete your undergraduation, like that is BSc. That should be with geology honors, and after that you have to complete your post graduation in either geology or in applied geology, or after through gate examination you can go through your higher studies with MTech in more specialization with mineral exploration and with engineering geology. Okay, after completion your masters, you have two option, two career path. You can choose your career option with research, that you will become a doctorate with you can proceed as professors in several universities. And either you have option like as industry expert, as a mining geologist, or either as exploration geologist, like in engineering geologist also. You can have your career option in oil and gas industries also.
Sir, after hearing so much about geology from you, I want to know what inspired you to become a geologist.
Okay. Okay. Actually, from my early days, when during my childhood, actually, whenever I used to travel in the outdoors, like in mountains, in forests. Actually, that time a curiosity comes to my mind to how the whole processes actually occurs. Like how the mountains are in that shape, how it actually became. Okay, so that out of that particular curiosity, I have a mind to study of this how it actually forms, how the art shapes like this. So yes, that actually inspired me to become a geologist, to learn about the geo, like the art and the formation of its. Okay, so if you love nature, you can sound the music of the art, you can listen the sound. Okay, that actually gives the subject geology.
Very well said, that, sir. Geology is the music of Earth. Sir, could you help us to suggest some universities which offer this course? I'm very sure
Yes,
this will
sure.
be useful for our students.
Yes, sure. Yes, in India, like there are lots of universities nowadays. Here, actually, I'm listing few of them. Few of the famous colleges and the Delhi University, like for graduation, like Hansraj College, from IIT BHU, from Ferguson College, from AMU, from Jadavpur University, lots of universities. Okay, that they offers the graduation like BSc degree in geology honors. And for for MSc, you have to crack JM, joint entrance examination, to pursue your post graduation through IIT. Like there are several IITs like IIT Bombay, one of the famous, IIT Kharagpur, IIT ISM Dhanbad, and IIT Roorkee. There are lots of universities are there, like University of Delhi, Kolkata University, Hansraj University. Yes, all over India, you can find lots of universities for graduation as well as post graduation in geology.
So, sir, if I will study so hard, what are the job opportunities after completing the completion of geology course?
Yes, definitely. That after completion of the masters, that question comes to our mind, that after completion of my masters, what will be the job opportunities? Like I can say the most prestigious job in India as a geologist, and this is Geological Survey of India. I'm telling you why that is most prestigious job. This is a job of government of India, and you are parallel to IS level, that is central gazetted grade officer. Okay, so in that particular way, that is the most prestigious job. And also government organization, different government organization offers a job as a geologist, like Indian Bureau of Mines, Mineral Exploration Corporation Limited. All the states have its own department of mines and geology. There you can join as a geologist. Like you can join in NMDC, National Mineral Development Corporation, in Steel Authority of India Limited, SEL. There are mining companies, several mining companies in India and as well in abroad also. You can choose your career path in oil and petroleum sector also. Several construction companies, like the companies that made up tunnels, they actually hire engineering geologists in India as well as in abroad. And as I said, research opportunities that you have, that is open for you all over the globe.
So I must say we have a plenty of scope after completing the course.
Sure,
So could
sure.
you please tell us more about the career progression as a geologist?
Yes, after starting your career path as a geologist, then you can promoted to senior geologist, and after you have to control the total team as a section geologist, and also as higher team in as a divisional geologist, and ultimately you can achieve as up to general manager level. There you may have the opportunity to handle a company total team of a not only for a geologist, but a geologist can reach up to a general manager post.
Dear all, if you have any question for our expert, please type that on the chat box. So would you like to share any personal challenge that you might have faced while completing your study, and how did you overcome that?
Yes, during my study and during my career days, being a geologist, I have faced several challenges. Uh, like whenever you are studying that subject, sometimes it feels a bit boring, like all the science subject as are. But whenever you are correlate these things with field knowledge, that is a mandatory part of a geologist to becoming a geologist, that during coursework of graduation and post graduation we have to make sure that we are in the fields to correlate these things. Then you can feel better that yes, that the theory part we have learned in our classroom, and yes, now we can correlate how it actually is, and how the formation was, that you can correlate. Okay. And during career path also, there are several challenges, like we have to explore new. For that you have the opportunities to work in some remote areas. Okay. Now, there you can don't even found mobile network, or there are several challenges. But at the end of the day, when you discover something new, you discover a high potential area. Okay, that actually feels you better, because you are a part of your nation building process, and you are discovering our daily life uses of every people of your country. You are contributing, you are the person who are contributing your country, your nations, every individual. So that makes you feel much better, that every obstacles, every challenges, that feels you completely better, that I
Sir,
must
I
say.
must say that this is a learning lesson for us. We understood that challenges are a part of our extraordinary journey. So we should keep trying to achieve our goal. So would you
Yes.
like to share any fun experience with us? I'm sure you must be having some fun experiences as well.
Yes, during field work, we have several fun experience, like during field days, we used to steal fruits like bananas, mangoes from the nearby villagers, and have lunch with them also. They invite us to take the lunch with them, because there are some areas, some remote areas where you can't find that kind of your lunch what you are expecting for or looking for. So yes, these are the fun experience one must have, and this is a part of the geologist, part of life of a geologist.
So any word of wisdom for our young learners who have attended our session today?
Yes, for that I'm starting with that. How many of them are ever heard the subject name geology? I think few of them, very few. You can type in the chat box. Like in my school days, I never heard. For my personal experience, I can share that. So I'm wondering how many of you ever heard the subject. There's a subject called geology. Uh, Still, yes. Many of few of them, I think, you have ever heard the subject. And like if you want to be a geologist, you must have the passion to you know to discover something new, and you have to accept the challenges, you have to travel, and as I said, then only you can achieve the goal of the nation building processes. Okay, that's all about, if you have the passion, then you must come to the you can become a geologist, good geologist, definitely. And yes, you have
Thank
to
you so much, sir.
yes ma'am.
Thank you so much, sir, for an insightful discussion. I'm sure it will help our students to have a clarity about the topic as well as relevant career aspects. Now, let's quickly summarize the career aspects. We have discussed about aircraft structural analysis engineer, material scientist, mining engineer, manufacturing engineer, orthopedic surgeon. You can be a geologist, astronaut mining, transplant surgeon, dental surgeon, metallurgical engineer. So you can choose any of the career after studying all about metals. Let's summarize today's learning. We talked about properties of metals and non-metals. We also talked about uses of metals and non-metals in our day-to-day life, metallurgy, application of rare earth metals, next-gen technologies, career pathways to become a geologist, and the importance of geology. There is a Google form link. I would request Arjun to share the Google form link in the chat box to have a quick check for understanding. This is all from my side. Now I would like to call Arjun to take over for feedback form and the vote of thanks. Arjun.
Megha and Sabir sir, this was wonderful today. Very good presentation, a lot of useful information about metals, non-metals, career as a geologist, and all other careers that people can look into, our students can look into becoming, as and when they start deciding what careers they want to go into. So before we start having questions for our speakers today, I would like to talk about our upcoming session from Adhyaapan. It's going to be a physics-based session next week, guys, and it's going to be on force and motion. I will share the registration form with you on chat box right now. If you haven't registered already, please make sure you go ahead and register for our upcoming physics session. And this is going to be next Sunday, April 24th at 10 a.m. Indian Standard Time. So I look forward to seeing you all in the next session as well. So I'm sharing another link with you guys before we get into questions. Anshu, I know that you asked a question to Sabir sir. I'll ask him that. Before that, please also make sure you guys fill out the feedback form for us, and this will be very useful for us to understand how we are doing, what can be improved, and to make sure that we make sure that we offer better sessions from now on. So thank you guys for attending sessions today. So we'll start having questions. Mr. Sabir, Anshu had a question that
Yes.
you were talking about post-graduation in geology and
Yes.
or actually undergraduation in geology with applied, I think with honors. Anshu had a question if you can have a degree in like biology or chemistry and also get into being a geologist.
No, Anshu, you have to complete your degree in graduation in geology honors only. Then you can have the opportunity to pursue masters in geology. Then you can, from biology or in from chemistry background, you can't become a, you can't even complete your post graduation in geology. Welcome.
Any other questions from anyone for our speakers? Can wait for a few minutes more if you guys have any questions before we wind up for our day today. Any questions, guys? Going once. All right. Looks like we have no more questions. Megha and Sabir sir, thank you so much for your very like, informative and engaging session today about metals, non-metals, and careers in the field of geology. So thank you guys for today's session. Thank you all for attending today's session. And we will look forward to having you all on our next session next Sunday on Force in Motion. So you guys have a great weekend and we'll see you next week. Thank you guys.
Thank you.